This power conversion unit takes care of all the power that's coming out of the B field presently and converting it from DC form to AC, where it goes into the high school. So the B field at present is producing 20 kilowatts of power and pushing out into the high school in AC form about 17 kilowatts. These lights that appear are the trouble lights, and when they are illuminated, that's how we know there is a problem with the inverters, and that very rarely occurs. If there is that circumstance, we're able to reset this power conversion unit or inverter by pushing the reset button. This is a corresponding unit, and it takes care of all the DC electricity coming out of the A field and converts it to AC electricity to be used by the high school. It is presently producing 20 kilowatts in the A field, and it's pushing out 17 kilowatts of AC electricity into the high school. These are duplicate models, and there are only two other pairs that exist like this in the country. So they are very unique. This is the weather station that gives us 7 points of information on our computer. Starting at the top is the anemometer, wind direction, the aspirator, this horizontal pipe that contains a thermometer that gives us Celsius and Fahrenheit readings, as well as dew point. And the barometric pressure is taken by this instrument here. Cumulative precipitation by the hour is collected here. And the only moving part on the entire field is this pyroheliometer, which is a tracker. And it begins each morning with sunrise and follows the sun across the course of the sky till sunset and automatically repositions itself at the end of the day toward the east. These instruments that we have here are giving further information to our computer. These would be the last 7 lines on the computer screen that we saw, because all of these instruments measure insolation. So we have reference cell on the array plane, which is a 50-degree angle to correspond with all of our subarrays, and a reference cell on the horizontal. Correspondingly, we have a pyranometer, which is on the array and also on the horizontal. And this one that you see here is the United States Government Department of Energy reference cell, which is a sample cell, which is also being tested on this site. So from this base, we see the 7 lines of weather data and the 7 lines of insolation readings. So this is the heart of the monitoring aspect of the field. Now, the results of these instruments are fed to the computer, and also any meters that appear, like in the inverter house where we were, are monitored by Massachusetts Electric on a monthly basis. They take the readings monthly, I take the readings weekly. Now if you'll join me down between the 2 subarrays, we'll talk about how these panels are wired together. Now in the visitor center we talked about the module that was there, and when they are placed 2 together over each other, 2, 2, 2 until we have 10, that's called a panel. And if you let your eye follow along, you see that there are 8 panels that make up one subarray. And then after the major break we see another subarray. So each row has usually 2 subarrays on this site. At the very end of each row is a junction box, and the junction box takes the power from the 2 subarrays in that row. Now, if we could look at the back of the panels, each module has a junction box which connects it to the main junction box, and that power comes into the conduit pipe, which, if you let your eye follow, connects to the next subarray and then into the junction box there. Each of these subarrays are secured to the ground in the event that we suffer hurricane winds. And the way these are secured, there's no question in our mind they won't be moving. The site has 6 lightning rods that each stand 81 feet high, and they are located throughout. This concludes our tour for today. Thank you very much for being with me, and I hope you enjoyed it.